My name is Samson, and we are the B team. We're going to be talking about the feasibility of air source heat pumps that was introduced during the beginning of the semester by Jamie Skimming and also by City Studio London. So the B team consists of me, John, Tim Tibor, Sasha, Dan M, Dan H, Kristen, Emily, and Helia. Right. So I offer this slide for you guys as a roadmap. With that being said, throughout the presentation, we'll be discussing what the purpose of the project is, what is an air source heat pump, the explanation of our analysis and our findings, and based on an environmental evaluation, a financial evaluation, and a behavioral evaluation, and finally our conclusions and our key findings. And just a heads up, we'll be switching over screen sharing privileges between each major section. So starting off, on April 23rd of 2019, London City Council declared a climate emergency, joining a growing number of municipalities globally who recognize the need for intangible climate change mitigation and adaptation strategies. So in order to kick off initiatives that will address these strategies, the City of London is in the progress of developing the Climate Emergency Action Plan. There'll be an attempt to lower the greenhouse gas emissions within the City of London. So in Ontario, overall, over 58% or 3 million of homes relies on natural gas as their primary supply of heating fuel. So buildings account for approximately 1/4 of total greenhouse gas emissions in Ontario. And on the other hand, in London, over half of all the greenhouse gases come from housing and personal vehicles. So it is important to know that decarbonizing residential gas heating faces major policy and financial barriers and other technical and logistical challenges. So this brings up the question of how we can reduce these emissions. So the problem is that we need to heat all our homes. Luckily in Ontario, our electricity grid is very clean due to the abundance of hydro and nuclear power at our disposal. This brings out the question of why not heat our homes during using electricity to reduce your emissions, and brings out the topic of our study. So a suggested solution is to change as many Londoners from natural gas space heating, which represents nearly half of our greenhouse gas emissions, to an alternative source of heating, which would use electricity instead. So the suggested alternative source for home heating, which will replace natural gas furnaces, are air source heat pumps. So based on the Future of Home Heating report from the Mars Advanced Energy Center, an environmental, economic, and behavioral perspective. Based on the Future of Home Heating report from the Mars Advanced Energy Center, the City of London wants to determine what home heating could look like from an environmental, economic, and behavioral perspective for Londoners. So an air source heat pumps could potentially be a possible method that we could utilize to lower our greenhouse gas emissions from our London housing stock. So now I'm going to pass it on to John to present how an air source heat pump works.
Thanks, Samson. So really, in order to be able to understand what we're going to be going through here today, it's important that you guys know exactly what an air source heat pump is. Basically, a air source heat pump is a home heating and cooling appliance in the same way that you would have a forced air furnace. The difference, though, is that air source heat pumps take the ambient heat energy out of the air and condense it to be able to heat a coil to provide warmer air to use within the home so that less electricity needs to be used to heat that air. It's a very efficient process. Now, the heat engine, the way that it works is that it has a refrigerant cooling in it. Samson, if you could go to the next slide for me, that has a coil running through it and it brings in cool air. And this works even below zero. There's still energy in the air, even if it isn't very much. So the idea here is that any heat that is there is sucked in, and then electricity is used to heat it the rest of the way. So the purpose of this project here is going off of a previously done study by the Advanced Energy Center from the Mars Clean Tech Incubator. So their findings found that there is a higher cost for full electric and hybrid scenarios over having simply a natural gas baseline. The idea here is that air source heat pumps work at certain temperatures, but then they become inefficient the lower the temperature gets. So when you get to about -5, that's when you typically will find that air source heat pumps become inefficient. So for this reason, there are most scenarios that look into using an air source heat pump will do it in a hybridized scenario where air source heat pumps will be used until a certain temperature, and then natural gas heating will take over at that temperature difference. So if it's below that threshold, natural gas would heat the home. Now, the key assumptions that we made here were 3 different scenarios. Essentially, we were saying that at 5 degrees, -5, and -15 would be the thresholds where the change from air source heat pumps to natural gas would occur. And we will get into this in just a moment in our environmental analysis. But the idea here, again, you can see it in the graph, is that in the heating season from April to October, there's a certain amount of days that go below that threshold. Now I'm going to pass it over here to Sasha, and she is going to be able to start going into depth on our environmental findings.
Thanks, John. So as Samson and John stated previously, air source heat pumps can help to reduce greenhouse gas emissions by supplementing natural gas burning furnaces with electrical power. So the purpose of this section of the presentation is to quantify this greenhouse gas reduction. So just a brief explanation of what we're going to go through in this section. We'll take you through our method of analysis and then move through to explain what we calculated as the emissions reductions per household. We're also going to look at the total emission reductions for London at a couple of different implementation rates. We will also need to take into account how the warmer climate will affect the temperature threshold scenarios that John mentioned. So the couple research questions that we hope to answer here is just kind of as I stated previously, looking at the greenhouse gas reductions we can achieve from air source heat pumps, how this varies depending on the age of the home, our citywide greenhouse gas emission reductions, and the impact of the warmer climate. So the first thing that we had to determine when trying to calculate our greenhouse gas reductions was the amount of natural gas used by the average London home. So we used the Union Gas data provided by Jamie Skimming, and we were able to take the total residential natural gas consumption and divide it by the total number of residential accounts in London. So this gave us an average natural gas of about 2,200 cubic meters per London per year. Natural gas is used for different functions in the home, but the 2 main functions are water heating and home heating. So for the purposes of this feasibility study, we assume that other functions such as barbecues, gas stoves, anything that you're using for cooking was negligible. So we made the educated assumption that water heating consumes 19% of the total yearly natural gas. This leaves 81% of the natural gas to be used in home heating. So therefore, the average amount of natural gas used per household for heating is around 1,600 cubic meters per year. This means that on average, each house is going to emit about 3,000 kilograms of CO2 equivalent per year. So the next step was to determine how many days of the year we would be running the air source heat pump versus the furnace. We made an assumption that people will only really be heating their houses between the months of October and April. So this is a total of 212 days. So for each of these days, we used historical weather data from the past 5 years, and we identified the number of days that were at or above our scenario thresholds. I know John mentioned these briefly previously. We picked 3 different scenarios, a switchover from air source heat to natural gas at 5 degrees Celsius, -5 degrees Celsius, and -15 degrees Celsius. So for an example, you can see here that our top scenario of 5 degrees, the air source heat pump would only be used for an average of 66 days. And that's because there were only 66 days that were greater than 5 degrees Celsius between our months of October to April. So in this scenario, we'd be using the furnace at about 146 days And that's more compared to all of our other scenarios. So therefore, more natural gas will be consumed. So you can see that the lower switchover temperature of -15 degrees Celsius, we'd use the furnace less. So obviously this is relating to our natural gas consumption. The lower our switchover temperature, the less natural gas we are using. So this figure is illustrating the natural gas consumption for each scenario. So as you can see on the left here, we have the no air source heat pump scenario where this is just the furnace. And this is our highest consumption of natural gas because that is the only method we're using to heat our house. And then on the right, we have our lowest switchover temperature. So you can see that the greatest difference is occurring here between 5 degrees Celsius and -5 degrees Celsius. And this is because this is the range of the most frequent winter temperatures in London. So therefore, the most heating days are going to occur between 5 degrees Celsius and -5 degrees Celsius. So now that we understand the natural gas reductions when using this technology, we can finally answer our question: what is the greenhouse gas reduction from the air source heat pumps for the average London home? So the light green bar here is the emissions from the air source heat pump that are associated with the backup furnace. So this directly relates to my previous slide. This is the amount of natural gas we're using. However, this is not the only source of greenhouse gas emissions. When we're looking at this technology, we need to take into account the emissions from electricity. So that's what our dark green bar is representing here. So that is the total greenhouse gas emissions for each scenario. This is the combination of natural gas and electricity. So you can see here that for the furnace, the dark green and the light green bars are the exact same length. That's because we are not using any electricity in this scenario. It is just the furnace. And we're using the most amount of energy, the most amount of electrical energy for our switchover at -15. And that's because we are not only using the air source heat pump the most in this scenario, it's also working a bit harder because the temperature is lower. So the line that I have plotted on this graph is showing you the total emission reductions. And we just use the furnace as a baseline for this. So you can see here at 5 degrees Celsius, our total reduction is about 800 kilograms of CO2 equivalent per year. At -5, our total reduction of greenhouse gas emissions is almost 2,000 kilograms of CO2 per year. And at 15 degrees Celsius, our total reductions is about 2,300 kilograms of CO2 per year. So I'm just going to hand it over to Dan now, and he's going to look at how the age and size of a home is going to influence this reduction that we calculated.
Yeah, so how does age and size of home influence greenhouse gas reduction? So the first thing we needed to do is define what is a new home and what is an old home. And we did this by using a Stats Canada report, which is classified old homes as built before 1996 and new homes built since 1996. And then based on that report, and then we also made the assumption that the average detached home in London that would be implementing an air source heat pump would be 140 meters squared or 1,500 square feet. Now, based on those assumptions, we're able to calculate average energy costs or energy consumptions for new and old homes. And then from that information, we were able to calculate an efficiency between old and new homes in terms of heating. So we calculated an 8.8% efficiency differential between new homes and old homes. So what does that look like in terms of, or in regard to an average London detached home? Well, using Environics, we were able to calculate the percent of detached homes that are considered new in London and the percent of homes that are considered old, and we applied those percentages to the annual energy consumptions per home that we showed you just earlier. And then we were able to apply that 8.8% difference between new and old homes. And I think the key takeaways here, and it's fairly obvious when we plot it out, that implementing air source heat pump in new homes or new buildings result in larger greenhouse gas reductions. And this is solely a result of that new homes use less energy and therefore less emissions to heat. Notably, the largest greenhouse gas differential between new and old homes occurred at the 5 degrees Celsius switchover, where 112 kilograms of CO2 equivalent differentiation was calculated annually. It's important to note that these annual greenhouse gas reduction scenarios are based on current natural gas and electricity greenhouse gas emissions. So depending on what happens with our grid in future years, this could change significantly. It is expected that newer homes built since 2015, or homes that are currently being built, will have a greater heat efficiency. So this differential is likely to increase when evaluating these homes. We just didn't have the information at the time. So the next question we wanted to answer is, what will this do for citywide greenhouse gas emissions and at different implementation rates? So just for simplicity, we use 4 different implementation rates, 25, 50, 75, and 100% implementation. So that means, so 100% implementation would mean all detached homes in London would be implementing air source heat pumps. A fairly obvious trend, the more implementation, or the greater implementation, the larger reduction can be seen. And I think that the biggest takeaway that we can see from this graph is that air source heat pumps can have a significant reduction in greenhouse gas emissions in London. If you look at the best case scenario here, so 100% implementation at minus 15 degrees C, we could save an annual greenhouse gas, or we could reduce the annual greenhouse gas emissions by 290,000 tons of CO2 equivalent. Obviously, however, this is probably unrealistic, and we'll get into that, why this is unrealistic, a little bit later. So what does this look like over years? I think everyone's fairly familiar with this graph showing cities' greenhouse gas reduction targets to become carbon neutral by 2050, the green line indicating the yearly target. So what we did was we applied these implementation rates to 3 separate models. So the first model is we classified as a conservative model, and assumes a 25% implementation rate by 2030 and a 50% implementation rate by 2040. A progressive model that assumes a 50% implementation rate by 2030 and a 75% implementation rate by 2040, and an aggressive model which assumes a 75% implementation rate by 2030 and 100% implementation by 2040. And then we compared this to each of our switchover scenarios, so 5, -5, and minus 15. And what you can see is that that there is significant savings that can happen in greenhouse gas emissions depending on the implementation rate. The 5 degrees Celsius switchover scenario, we don't meet net zero emissions by 2050, but you can see how significantly it can impact greenhouse gas emissions from the City of London. When we get into the -5 degrees scenarios, when we actually start seeing net zero emissions achieved, depending on the implementation model, and then obviously for the -15, we see a greater or a quicker reduction. It's important to note here that we calculated these using current natural gas and electricity grid emissions. So depending on what happens in the future, specifically to our electrical grid, these numbers could change drastically. It's also important to note out here, even though we came up with 3 emission models, or sorry, implementation models, these are all still fairly aggressive, and we will explain why a little bit later in the presentation. So now I'll be passing it off to Samsung, who's going to be looking at the impact of future warmer climates.
So what impact would a future warmer climate have on lowering greenhouse gas emissions? So in order to calculate this, we need to know what the climate of London is throughout the year. So this chart illustrates the average temperature in London with the ranges of recorded temperatures for each month in a specific year. So temperatures are recorded in degrees Celsius, where it's coldest in January and February, where temperatures drops as low as -24.9 degrees and as high as 9.1 degrees. and it's warmest in the months of July, with temperatures reaching as high as 33.4 degrees and as low as 9.9 degrees. And based on this graph, temperatures are most stable in the month of December. So under intense climate change or high GHG emission scenarios, seasonal projections of average temperatures will slowly increase in the future within the time periods 2021 to 2050 and 2051 to 2080. And the projections are listed in this table. So from here, we added the seasonal projections to their respective heating months days, which is from October to April for 1 year. And with the climate data from 2019, we calculated the number of days the heat pump will be used for each switchover temperature. And it will be shown on the next slide. So as expected, with rising temperatures in the futures, the number of days to run the heat pumps actually increases in the future. For example, currently in 2015 to 2019, there are 60 days, 6 days are above or equal to the switchover temperature of 5 degrees, while in 2021 days, 78 days are above the threshold and 105 days are above the threshold in 2051 and 2080. So based on these numbers, this will impact the amount of natural gas used and the greenhouse gas emissions associated for each time period. So with more days used for the heat pumps and the less days used for natural gas, less gas is burned up as backup. And as a result, there's fewer greenhouse gas emissions. And you can see it on this graph right here. And under the -5 and -15 scenarios, switchover temperatures, this threshold temperatures emits the least emissions from natural gas and the greatest reductions. So in order to project the total greenhouse gas reductions in the future warmer climate, 2 electricity scenarios was utilized. So under scenario 1, we assumed emission factors for electricity in 2019 stays the same for the 2 time periods, which is 0.034 kilograms of carbon dioxide equivalents per kilowatts per hour. So the total greenhouse gas reductions represented in this graph includes both greenhouse gas emissions from natural gas and electricity. And you can see that the reductions increases for each switchover temperature within the 2 time periods. However, for scenario 2, alongside future climate projections, we also took into account projections of the emission factors for electricity. This is largely based on the fact that the clean grid that we have right now will not stay clean in the future. So upon my research, I found that the loss of nuclear energy with the closure of the Pickering station after 2024 and the combined closure of both the Pickering station and the Darlington station and the planned refurbishment of Bruce station until 2031 resulted in an increase in total greenhouse gas emissions. Because nuclear energy are relatively clean energy sources of energy, which basically means that they do not emit greenhouse gases, the loss of this capacity is replaced or substituted by the burning of natural gas using electricity. So as less nuclear energy is used to power Ontario, more stress is put on Ontario's electricity grid and becomes dirtier. This explains why the emission factors for electricity increases in the future. So from the forecasted emission factors that I found in the atmospheric fund report, we extrapolated the data to include the line of best fit with the help of Helia's engineering skills. And we assumed the electricity emission factors will continue to increase past 2035 and came up with these future emission factors for the time periods between 2021 to 2050 and 2051 and 2080. So in this graph, the total reductions in greenhouse gas emissions for each switchover temperatures include greenhouse gas emissions from natural gas and electricity yet again. However, under this scenario, the total reductions in greenhouse gases show a significant decrease and under a warmer climate and a dirtier grid compared to the current electricity rates and usage. Although these are just assumptions, it's important to recognize that the Ontario electricity grid plays an important factor in the overall reduction in greenhouse gas emissions. And now I'm going to pass it on to the economics groups who will now talk about the financial feasibilities.
Thanks there, Samson. I can take over the screen share as well here. Just one moment, everyone. I hope you can all bear with me. Now, there is a lot of information here to go over. If you've stuck with us so far, the premise of what we've been going through is that there is going to be a ton of different changes that need to be accounted for. There's a lot of variables that come into a scenario like this. What we're going to look at now is what are the actual financial costs for a project like this. The program here that we are going to start with is what are the costs of an air source heat pump look like, and then what are the impacts of things like the change in climate and the price of electricity or even carbon pricing have to do with that program. So what we were finding on a baseline study is that the upfront cost for an air source heat pump is around $14,000, and that's including some installation cost as well. And that's comparing that to a natural gas furnace at $9,300. Now, some of these costs can be shared in hybrid scenarios for installation, but it's still a really big ask to have people shell out that much money upfront to pay for these systems. So just to be able to keep this framed properly, remember that we are comparing these systems against a natural gas baseline where there is an amount that needs to be paid. So full electric air source heat pump scenarios have a lot higher energy costs, and they can change based on the systems that we look at. Interestingly, we found this hydro bill projections from a leaked Progressive Conservative Party document. This was released by CBC News in 2017. And this is what they're estimating people's monthly hydro bills are going to go up by. And there are a lot of things that can impact the monthly bills that people have. We've got the climate change again, the electricity rates, carbon pricing, and even the housing characteristics. As Dan had mentioned, the age of the home can have an impact on it as well. So what I'm going to do here is pass it over to Tibor, and he's going to break down the analysis we had done on the electricity rates and on the air source heat pumps themselves.
Hi. Yeah, so we were tasked with determining how the warming future climate will affect the cost of using an air source heat pump to heat one's home. And as we already mentioned a bunch of times before, air source heat pumps lose efficiency as temperatures decrease. So it would make sense that if average temperatures are going to rise, the cost of using the air source heat pump will decrease. However, based on Sasha and Samson's temperature projections, the actual number of days in the heating season where the average temperatures are over 5 degrees is set to increase dramatically. And so the number of cold days is set to decrease. This means that someone who only uses their air source heat pump for heating when temperatures are above 5 degrees Celsius will actually end up using their heat pump much, much more often over the course of the year. So I calculated the hypothetical annual power draw of an air source heat pump in London, Ontario, based on future predicted temperatures using this Mitsubishi Mr. Slim model. So I picked this model because it's got a high heating capacity at low temperatures and also a high efficiency. But there isn't really anything special about it otherwise. There's a great deal of air source heat pump models that can function at low temperatures, each with their own performance numbers. But the availability of these performance specifications, especially for lower temperatures, is pretty poor. So the availability of this performance data is another reason I chose Mr. Slim. In order to make these models, I also made the assumption that Mr. Slim is operating at maximum capacity at all times of the day. So keep in mind that these numbers aren't really realistic as to how much it'll cost. It's mostly comparative. So we can kind of we can compare how much it'll cost in the future, basically. And as you can see, the energy cost of heating your home with an air source heat pump will increase in the future if you're switching over at a temperature of 5 or -5 degrees Celsius, but only because the amount of days where you're using that heat pump is going to increase. Now, if your switchover temperature is -15 degrees Celsius, which basically means that you're using your air source heat pump for heating almost 100% of the time, your annual power consumption will decrease slightly, thanks to the higher average temperatures in the future. And so this is basically the exact same graph, just in terms of dollars, but using a fixed electricity rate of about 14 cents per kilowatt hour. So if you're using your air source heat pump exclusively, you will save money eventually. However, those predictions are just based on today's electricity prices. And as we've mentioned multiple times, we know that the cost of electricity will rise. It's really difficult to forecast this rise over the next 6 years, and we weren't able to actually find a good model for it. So we extrapolated future prices based on the rise of electricity in Ontario over the last 14 years. And this is what we got. So taking the increased cost of electricity into account, we see that the cost of operating air source heat pumps for home heating will increase greatly. And while it's true that this is just a crude linear projection of the price increases and eventually prices will level out, and some of this price increase is also just due to inflation, it still seems like it'll be way, way, way more expensive than can be affordable. So there are some other variables to consider here too that might incentivize people into using air source heat pumps, which includes carbon pricing, which will increase the price of natural gas. And I'll pass it over to Helia to talk about that.
Thank you, Tibor. So here we want to answer the question that what impact does carbon pricing have on lowering dollar per month at $50, $100, and $200 per ton of emission? So what essentially we did for this slide is that we calculated the annual GHG emission reductions from electrified heating. So we considered switchover temperatures as well as different periods of time. And based on the equation under the table, we assume that the heating is used during the months of October to April, and the emission factor is constant. So the effective variables for this equation would be natural gas usage, which is based on the consumption, the carbon pricing, and switchover temperature. So in this slide, we estimated the annual savings under different carbon pricing scenarios. So the current carbon pricing in Ontario is $30 per ton of emission, and it is going to raise $10 each year according to the current legislation. So it's going to hit $50 per ton of emission in 2022. So we have assumed the carbon pricing of $50, $100, and $200 for the period of 2021 to 2018. And as you can see here, the largest numbers, which is in red, are related to the highest carbon pricing and the lowest switchover temperature, which is probably happening because based on the projection of Sasha and Samson, we're going to have warmer climates in future. So now we want to know, what does this mean for the average homeowner? This slide represents the carbon tax saving for $200 per ton of emission for the current year and the following decades. The current saving in 2020, which is the bar in the lightest green, is very minimal, but it increases considerably in future years. So however, the real savings of the project would be less than this because we're having the electricity source, actually the electricity source would be probably dirtier in future, and there would be carbon tax associated with the electricity bill. And now we want to know, how much will this cost the average homeowner? So the net savings of this project consists of two parts. The first one is carbon tax saving related to natural gas. And the second is natural gas saving because you're using less. So the green bars represent the net saving for each switchover temperature and timeline. And the red bars show the surplus of electricity costs associated with our source heat pump. So as you can see here, there is a notable and huge difference between the savings and the cost. So if we want to make the project financially feasible, hopefully and probably the local government should allocate incentives for the project implementation actually.
So just to be able to keep everyone's mind on the same track here, the cost for the average homeowner, if they were to use air source heat pumps, is very high. You can see in yellow there in the bottom right of the table, $820 is what the expected electric bill would be for the average home in London if they were to use air source heat pumps all the way to negative 15 degrees Celsius. Again, there are a lot of variables that we're not taking account for here, but it is important to keep in mind electric heat is very expensive currently. Now, what we really need to know then is assuming that we know how much greenhouse gases can be saved and assuming we know how much the costs will be to use electric heating, who would even go after it? So I'm going to stop sharing my screen here and pass it over to Kirsten, who is going to share and go over the findings that we had of our Environics data.
Can you guys see my screen?
Yep.
Yeah, you're good. Go ahead.
All right, so the behavioral section is going to be the last leg of the presentation here. We're going to tackle questions such as, what is the willingness to pay more money per month for zero emissions in London? Who is willing to pay more money per month for these zero emissions, and where do they live in London? And then also, are there any sweet spots within the city? So the behavioral team used Environics data analytics software provided by Jamie Skimming to create 45 reports, each unique to a London neighborhood. So each report provided us information on the neighborhood demographics and psychographics. So on this slide here, we just have a few examples of the type of demographics we were able to analyze, and that's where we're going to start off the behavioral presentation. All right, so this figure here demonstrates the population of London neighborhoods. So in this figure, it's important to note that the population is most dense in the city core. And this is just something we'll want to keep in mind as we move throughout the rest of the behavioral presentation. So moving from population, we're now going to look at the average household income of London neighborhoods. So in this figure, we want to pay attention to the greatest household incomes being situated along the north/northwest city boundaries, as opposed to the lowest household incomes, which are densely situated within the city core. Unfortunately, if we keep in mind the population graph from before, the areas with the lowest income also happen to be where the greatest populations are. All right, so this figure here looks at the average period of home construction in London neighborhoods. So in presenting this figure, it's important for us to note that the average London homeowner has previously replaced their furnace every 15 to 30 years. So that said, the homes built between 1991 and 2005, which are light purples in this figure, are coming up on needing their first home furnace replacement, while the homes built before 1961 are in the range of needing their second home furnace replacement. So the reason that this is notable information is because people are more likely to invest in technology when it's something that actually needs replacing, as opposed to just spending money on something to solely improve their carbon footprint. All right, so we also wanted to know where the number of homes were owned in London neighborhoods. And this was because homeowners are more likely to invest in green energy technology than renters. Renters are typically not going to invest money into a house that they don't own. So we wanted to see where the greatest number of homeowners were located in London. And as you can see, that's densely within the city core. Interestingly, however, when we look at the percentage of homes owned as compared to the number of homes owned, the map gradient actually inverts. So although there's a greater number of homes owned in the city core, this number reflects the greater population. So in fact, when we look at the percentage of people who own their homes in London neighborhoods, we see greater percentages along the city boundaries, which also reflects the average household income. So the higher income, the greater the percentage of homeowners. So in this regard, the city may be smarter to target neighborhoods based on the percentage of homes owned rather than the number. And although this is technically targeting less people, they would be targeting people with more disposable income, and therefore their efforts may be more successful. So lastly here, we're going to look at the number of single detached homes in London neighborhoods. This is because our project specifically focused on single detached homes, so we just wanted to give the city an update on where they could find the greatest number of these homes located within the city. So next, the Environics reports provided us some psychographics on environmental related issues and questions. So one example would be, I'm highly concerned about the environment, and 55% of people said that they were. So if we want to actually look at a map and a graph of the number of people concerned about the environment in London neighborhoods, we can see here these dark green areas are sort of the sweet spots where there's a high number of people concerned. Similarly, we wanted to look at the number of people willing to pay more for green products in London neighborhoods. So notably, there's little change with respect to the previous figure, which demonstrated concern. This figure in particular is considered one of the most important of the behavioral presentation, and that's because the air source heat pump will unquestionably cost London homeowners more money up front. So we really need to identify the areas of high willingness to invest in this technology. Interestingly, again, when we look at the percentage of people based on the environmental psychographics, the London neighborhoods don't demonstrate much variation. So the variation we were seeing based on the number rather than the percentage is very indicative of population. So this information tells us that most London neighborhoods are equally concerned about the environment and equally willing to pay more for green products. Unfortunately, it's also important to note that these percentages are relatively low. So the percentage of people concerned about the environment is all within under 50%, and the percentage of people willing to pay more is even worse at under 15%. All right, so we also wanted to take a look at the correlations between this demographic and psychographic information. So this figure in particular demonstrates the strong correlation between the number of people willing to pay more for green products and the number of people concerned in each London neighborhood. So as we can see, there's an extremely strong correlation going on here. So these dark green areas are going to tell us these are areas where people are willing to pay more and they're concerned about the environment. So again, these might be the sweet spots we really want to pay attention to moving forward, investigating the air source heat pump technology. So it was also important for us to analyze the correlation between the number of people willing to pay more for green products and the average household income of each London neighborhood. So as you can see here, there's a very weak correlation, almost no correlation between the two. This figure really highlights that it's not necessarily the people with the most disposable income who are actually willing to pay more for these green technologies, such as the air source heat pump. Moving forward, we also wanted to determine which Londoners had previously invested in green technology, as these people may be more likely to invest again in the future. So this figure demonstrates the percentage of people who drive an electric vehicle and the percentage of people who drive a hybrid vehicle based on their postal code region. So it's important to note that the overall percentages are relatively low, but a greater percentage of people have previously invested in the hybrid option. And the reason this is a notable fact is because the air source heat pump is sort of a hybrid technology because it is supplemented by the natural gas in the winter/extreme temperatures. So when we combined these two data sets to look at the percentage of people who drive an electric vehicle or a hybrid vehicle based on their postal code region, we can see that a sort of cluster is formed in the top region of London, which perhaps might indicate another sweet spot where this technology may be more likely to be purchased or installed. And then furthermore, Jamie also provided us with data on the number of home energy retrofits in London by the postal code region. So as we can see, another cluster has formed. We just wanted to mention that this data perhaps should be taken with a grain of salt, as this data does correlate heavily with the age of home in London, meaning that people may have invested in these home energy retrofits out of necessity as opposed to solely wanting to reduce their greenhouse gas emissions.
And then in terms of the social values of the psychographics results, the left side of this example in Veronic's page reveals the values that were rated the highest among the residents in their respective neighborhoods. We sifted through the strong values of each of the 45 neighborhoods in London that they rated the highest, selected certain values that we consider to be the most important in terms of our research questions, and then we filtered them into 4 subgroups of London residents that we believe that we should be focusing on. So for our first group, we call them the environmental pessimists. This group rated the following values the strongest: ecological fatalism, a tendency to believe that today's environmental problems are too big for any one person to affect. People strong on this construct feel that environmental destruction is somewhat acceptable and inevitable, and accept that the notion of protection or economic advancement should be allowed at the expense of environmental protection. They also view environmental leaders as misguided and overly extreme. Enemy aimlessness, the feeling of having no goals in life, experiencing a void of meaning with respect to life in general, a feeling of alienation from society, having the impression of being cut off from what's happening, and skepticism towards advertising, the tendency to distrust and reject advertising as a source of reliable information, also a tendency to reject the fashions and the role models promoted by advertising and the consumer society. So these are the residents who we believe will be the least likely to be influenced to install air source heat pumps due to their perception that environmental destruction is inevitable, their lack of motivation, and their distrust in advertising. For the second group of residents, we call them the persuadables. This group rated the following values the strongest: consumption evangelism, the desire to exercise real leadership among one's peer groups in adopting brands, products, and services. Consumers who are strong in this construct are enthusiastic, even passionate about what they buy, and are very well informed about product features and competitive products. These are the people others consult before buying something. Because of their large, well-maintained social network, they wield great influence when it comes to promoting a brand, product, or service. Status via home, feeling a strong sense that one's home represents an extension of one's image. People strongest on this construct make great efforts to decorate or equip their home in a manner that will impress others and pay particular attention to the way they entertain in their home. And confidence in advertising, the tendency to trust and use advertising as a source of reliable information. Also a tendency to identify with the fashions and the role models promoted by advertising and the consumer society. So these are the residents who we believe can be more easily persuaded to utilize air source heat pumps due to their desire to be the first to have the newest products and services, their large social network of which they have a great influence over, and their great efforts to equip their homes in order to impress others, as well as their increased likelihood to be influenced by advertising. For group 3, we call this group the environmental sustainers. This group rated the following values the strongest: ecological concern, a tendency to believe that today's environmental problems are a result of industrial and personal disregard for the environment. People strong on this construct feel that environmental destruction is unacceptable and reject the notion that job protection or economic advancement should be allowed at the expense of environmental protection. They also reject the idea that any one person is too small to make a contribution to this project. Primacy of environmental protection. People strong on this construct prioritize protection of the environment over economic advancement and job creation that could threaten the environment. And then also attraction to nature, how close people want to be to nature, whether to recharge their spiritual batteries or to enjoy a simpler, healthier, or more authentic way of life. So these are the residents who we believe will be more willing to have an air source heat pump installed due to their appreciation for nature and their desire to protect the environment. And then our last group we call the future planners. These residents rated the following values the strongest: legacy, the desire to leave behind a legacy after death, either to one's descendants or to society at large. This legacy could be a financial, cultural, moral, or spiritual nature. People strong on this construct tend to plan their bequests well in advance. North American dream, the belief that, like the United States, Canada is a land of opportunity and that anyone can make it and make it big if they try hard enough, i.e. the American dream. The belief that even in middle age, one can start anew, launching new initiatives or changing one's way of life. Financial security, a feeling of security and optimism about one's financial future, a sense of being personally responsible for and in control of one's financial situation, and also fulfillment through work. So a need to invest in one's professional life with meaning and to find personal fulfillment through one's work. Also a need to feel that one's work is useful to others and has some social value. So these are the residents that we believe could be influenced to have an air source heat pump due to their financial security, their desire to be useful to others, and their focus on and optimism for the future. So then we determined which of the 45 neighborhoods in London rated our chosen values as their top 3 strong values, utilizing an index a scale of 1 to 3, with 1 being the strongest rated value. We then produced the following results regarding the neighborhoods that will be the most or least likely to purchase air source heat pumps. So for group 1, the neighborhoods that rated the values within the environmental pessimists group, their top 3 strongest values were Glencairn, Bostwick, Longwoods, and South London, with Glencairn rating the highest. These neighborhoods are located around the central to south areas of London, as denoted on the map. So based on social values, these are the neighborhoods in London that are the least likely to install air source heat pumps in their homes due to their distrust in advertising and disregard for environmental sustainability. For group 2, the neighborhoods that rated the values within the persuadables grouping within their top 3 strong values were Fanshawe, Hyde Park, Stony Creek, Fox Hollow, and Talbot, with Fanshawe, Hyde Park, and Stony Creek rating the highest. These neighborhoods are located around the north and west areas of London, as you can see on the map. And then in terms of social values, these are the neighborhoods in London that can be more easily persuaded into utilizing air source heat pumps due to their increased likelihood of being persuaded by advertising, their consumption practices, and their strong sense of status via home. For group 3, the neighborhoods within London that rated the values within the environmental sustainers grouping within their top 3 strongest values were Airport, Argyle, Bradley, Brockley, Crumlin, Glanworth, Highbury, Jackson, Lambeth, Old Victoria, Sharon Creek, Tempo, Huron Heights, South London, East London, Glencairn, and North London, with the majority of the neighborhoods rating quite high. These neighborhoods are mostly located around the eastern and southern ends of London, as you can see on the map. So in terms of social values, These are the neighborhoods in London that will be more willing to purchase air source heat pumps due to their desire to protect the environment. And then lastly, for group 4, the neighborhoods within London that rated the values within the future planners grouping within their top 3 strongest values were Stony Brook, Oak Ridge, Sunningdale, Uplands, Westmount, Hamilton Road, Highland, and Masonville, with Stony Brook rating the highest. These neighborhoods are mostly located within North and Central London, as you can see on the map. And then as a result, in terms of social values, these are the neighborhoods in London that may be more likely to purchase air source heat pumps due to their financial stability, focus on the future, and their desire to leave behind a legacy with a strong social impact.
All right, so as shown by the Environics reports that we created, we can see that there is a plethora of factors to consider when discussing who in London is most likely to install air source heat pumps in their home. Through the use of demostats, Vividata, and Prism data sets, we were able to gain perspective on a range of general demographics, as well as important values and attitudes towards sustainability across 45 different neighborhoods in London. While we did notice trends in terms of which neighborhoods were in the best position to buy and install air source heat pumps, we determined that the highest income were unlikely to be our target audience. Instead, our main findings suggested that middle-class income homes with positive attitudes and values towards the environment were the ideal target communities. To fortify our estimations, we have decided to investigate current market research trends as well. This has also given us the opportunity to account for more widespread behavioral changes attributed to the COVID-19 pandemic. We will begin by looking at more generalized behavioral changes and how they contribute to the choices we make. So first, we see a trend towards minimal consumption, where there's a greater emphasis being placed on the affordability and convenience of goods and services. Along with this, we're seeing more value being placed on efficacy, flexibility, and durability. After experiencing being confined to your home, having limited access to resources, and a reduction in job security, people are more cautious of their spending habits, especially on novelty goods or goods that don't serve a purpose. Another trend we're seeing is increasing value being placed on the circular economy model. People are valuing reuse and recycling over excess wasteful consumption. Finally, the pandemic has altered our idea of stability and permanence, and people are feeling more financially vulnerable. Consumers are reevaluating how they spend their money and what their money is worth. Consumers are now avid about knowing what a project is going to cost, not just initially, but in the long run, and if there's any associated costs. Additionally, people want their choices to be impactful and produce a certain outcome. These shifts can play a substantial role on deciding whether to install a heat pump or not. This may cause people to either hold off on making any significant financial decisions, and conversely, for people who already place high value on the environment, purchasing a heat pump may be more efficacious decision. We would suggest either marketing the heat pump or creating educational tools which emphasize the value of switching to a hybrid heat source, as well as very clearly laying out the cost of the system and projected cost of running it. This data that we also gathered from the Mintel group also gave insight into how shifting priority trends will continue to influence consumers in the future. The first emerging trend we see going into 2021 is the increase in the importance of budgeting. So things like installment spending is becoming a more popular concept, and people are now wary of being caught off guard without money, especially with the uncertainty of the pandemic. Air source heat pumps may be more appealing if consumers were able to spread out the initial cost of the unit and the installation over several payments. In saying that, consumers are also redefining what they view as affordable. So purchases that once may have been within reach are now considered not financially feasible. This leads to our next trend of redefining luxury items. So moving away from aesthetic and more towards practicality and lasting value. So here's another instance of how dissemination of information can play a role in consumer perception of heat pumps. So finally, we're seeing a shift in consumer trust and loyalty. So throughout the pandemic, consumers have become more critical of information while placing value on adaptability. Consumers are now more trusting of companies and brands that are making gradual changes to sustainability and more skeptical of companies or brands that use blanket statements like, "We're making big changes." Consumers are also more willing to stay loyal to the companies that are willing to adapt to the pandemic and post-COVID life rather than try and return to the way things were before. The implications for heat pumps here can also be significant by creating ties to strong sustainable values and emphasizing that hybrid heating is a gradual stride in the direction of sustainable energy and may allow for consumers to be more susceptible to the idea of installing one. In addition to trends, we also investigated attitudes towards sustainability. Earlier on, we used willingness to buy a hybrid car as an indicator of willingness to buy an air source heat pump. So to further look into this, we analyzed the Automotive Innovations Report of Canada, the Hybrid and Electric Vehicle Report of Canada, and the Automotive Innovation, including impacts of COVID-19 report for Canada. What we found was that government incentives and the savings in fuel over time were the main drivers in making the choice to switch to hybrid vehicles. What we take away from this is that costs associated with switching to a hybrid model may have been too much for the consumers to buy on their own, but with the help of government incentives, it was more attainable. It was also help indicate the type of income people who are buying hybrids have. So another takeaway from this is that the associated long-term savings were important to consumers, further emphasizing our thoughts on portraying the heat pump as something that saves money in the long run. An interesting note we found was that the interest in hybrids had declined due to innovations in fuel economy for conventional gas cars, which also may point to innovations in heating systems such as smart thermostats as being a deterrent to air source heat pumps. Since the onset of the pandemic, as previously mentioned, affordability became more of a concern and consumers are being more cognizant of their spending. However, the research also indicates that many consumers were saving money that would have been utilized for vacations, entertainment, and childcare, and are more willing to use those savings towards innovation specifically. Another deterrent was the concern about reliance, cost of repairs, and being able to have any problems fixed during the pandemic. So in terms of attitudes, our most salient takeaway from the data that we found was that even though there are several factors deterring consumers from investing in hybrid cars, the belief that climate change is significant and that hybrids are the way of the future is still unwavering. So for people planning to buy cars who are considering hybrids in the next 3 years, 29% of them were between the ages of 18 and 34. This statistic remained the same for those who made either below 70,000 or above 70,000 as well, so cost wasn't an issue. 26% held university or postgraduate degrees. This dropped to 21% and 16% with those with college diplomas or high school diplomas respectively. 29% were in a household of 4, which dropped significantly to 15% for single person homes. And 24% were full-time workers, which dropped to 20% for part-time and then 15% for retirees. And then 24% of them had money left at the end of the month for savings or luxury items. And this dropped only slightly for those who are getting by or those who are just making ends meet. Another area we investigated to determine behavior was values. So this data is from the Ethical Consumer Report of Canada, which came a month before lockdown began. So shifts due to COVID-19 are not accounted for. The distribution was very small across the board on various statements on sustainability, as we also saw in the Environics reports, typically pointing higher for older generations. The area that we found the largest distribution was in homeowner status. So those who own their homes or those who are living in a home rent-free saw the largest discrepancy versus those who were 18 to 24, or sorry, those who were renting. The second biggest discrepancy we found was people over the age of 65 were most likely to place importance on energy efficiency rather than ages 18 to 24. This led us to believe that in older age, consumers are more likely to own their homes and are more likely to be conscious of spending as they head towards retirement, but overall appreciation for sustainability appeared to be consistent. The final area we looked at was market trends for renovation projects in Canada, using the renovations priority among Homeowners in Canada report. What we are looking for here is trends in types of project, how consumers are paying for the projects, and how much they're willing to spend. This will help give insight into general interest in sustainability, and along with an estimate of how much people are willing to pay for innovations. So what we found that while the top priorities may be attributed to aesthetic of home, energy efficiency, which is in 4th place, is still a high-ranking reason for renovation. It is also worth noting that this study was conducted before the pandemic, and if the findings from our more recent research extends to renovations, we would also see a shift to prioritizing functional and valuable upgrades over aesthetic ones, especially if people are using their savings. So this would also be applicable to our findings because we determined the sweet spots in London to be in older homes in the east and south ends of the city. And these are also the homes most in need of renovating, especially in up-and-coming areas like the Old East Village. This leads to our next finding that 80% of the cost of renovation projects is being paid for by cash or personal savings as opposed to credit cards or online or lines of credit. And then even though the highest represented group is still spending less than $2,000, sitting at 47%, there's still a significant proportion spending between $5,000 and $20,000, as we can see. And also the average per year, even though it's dropping, it still remains over $10,000. So even though this is still around $4,000 short of the cost of the air source heat pumps, there's also the possibility of installment plans to encourage people to make the change to a hybrid model. This can be further strengthened by thorough education and information on savings potential and the value of hybrid systems. Other areas we investigated which lack sufficient information was the demographics on those now working from home for the foreseeable future and how their behaviors have shifted. And then also if London was seeing a significant amount of potential buyers moving from Toronto looking for more affordable housing. So we look forward to facilitating further discussion on subjectivity of behavior and how we can promote sustainability.
Yeah, so tying all our conclusions together and kind of giving the key takeaways from our research thus far, in terms of environmental perspective, the implementation of air source heat pumps can have some significant greenhouse gas reduction capabilities in the City of London, particularly in aggressive models. It can really help in meeting our 2050 target of a net zero. However, future considerations of Ontario's electricity grid plays a huge role in overall reductions. If our grid is to become dirtier in the future, this is going to have some fairly significant implications on the implementation of air source heat pumps.
Now, financially, air source heat pumps right now on their own would not be a viable financial option for the majority of consumers. The climate change scenarios will mildly affect the total costs, but not enough in a way to be able to justify it on its own. Similarly, aggressive carbon pricing would be necessary to bring the bridge between natural gas pricing as it is right now closer towards electricity. But as Dan just mentioned, the issue that we have here is that the electricity grid is going to get more expensive as time goes on, and it is not going to be working. So some further research that would be very beneficial to look into is the different possibilities for electricity rate structures. Some jurisdictions in the States have a separate rate that is used for electric heating, which does allow them to be able to bring costs down for some homeowners. Similarly, the incentives that might be able to be applied, or as Dan McGregor had mentioned, using some installment plans might make it more lucrative for a homeowner to switch over to an air source heat pump. And very importantly is that more energy efficiency programs would need to be run to reduce the required amount of heating so that during the winter, those electricity bills don't skyrocket as high.
All right, and then just to conclude for the behavioral section, as a result of our findings, we feel that it would be best to target neighborhoods who have a high average income and are willing to pay more for green products, as well as the neighborhoods who have strong environmental values. So that's going to be areas that are both dark green in these maps and dark orange, where there's heavy overlap, as well as going to be wanting to target those older neighborhoods who are going to be looking to replace their home furnaces anyways in the upcoming years. Obviously, there's still a lot to be done with respect to the air source heat pump research, but we really appreciate you listening to our presentation, and we're happy to accept any questions.
Great. Excellent work, everybody. That's great. Lots of really detailed analysis there, and I think I might just open it up for questions. Maybe we'll go first to our guests, give them first crack.
Great, thanks, Brennan. And I think the first thing I'd like to say overall is I think you guys did a fantastic job with this. This was, definitely a very thorough analysis, and especially looking at all the different aspects of that. So once again, I do want to say congratulations for undertaking this project. I know I did have a couple of questions which I just kind of noted when I was going through, and I guess one of the questions I had was, especially when it came to sort of on the economic analysis, is we know that, and also this will vary by temperature, but we do know that with heat pumps that there's what they call the coefficient of performance. In other words, you're getting 3 or 4 or 5 units